In this video, we are going to talk about analog input. Let's begin. So first, we are going to cover on analog versus digital. What's the difference? Then we will be talking about potentiometer and music using the piezo and the potentiometer to create a piano. So next is the temperature sensor. So we'll end off with that. Next. So let's talk about lighting. So instead of on and off, too extreme the digital is only on and off. We can actually adjust it in a gradient. So instead of on and off, we can dim the lights, or we can adjust how we want it to warmer or cooler. Okay, so if you want to do this sort of thing, you want to dim the LED, you want to adjust the warmth and brightness, actually analog signal will be able to do so. So instead of just on and off, we can do a lot more things. So analog is just like life, it's not extremes. It is like example, how's your day on a scale of 1 to 10. It's not I'm happy or unhappy, but it's maybe on a scale of 1 to 10 you are always 7. Okay, so let us continue. So analog signals are read from pins A0 to A5 of the SSTuino. So these are the analog pins. Then so you can actually see it on here. So you can actually see these are the pins. Okay, so it maps inputs from 0 to 5 volt to 0 to 1023. So like this chart here, this bar chart here. So 5 volt is 1023, 0 volt is 0. So from 0 to 5, how do you actually convert 1 volt? So what is 1 volt? 1023 divided by 5, you get 204.6. Then let's say you want to say 2 volt, you times 2, you get 409.2. So roughly it's an integer, so you just remove away the decimal. Okay, so that's about how they actually do this. Now if you want to convert numbers, how do we convert numbers to voltage? Okay, from the reading, always the sensors or the how it do the analog reading, it will be 0 to 1023. And how can we convert it to meaningful data? So first thing is we should convert the numbers to 5 to the 5 volt, 0 to 5 volt. So how do we actually do that? Let's say the number that is given is 614. So 614 divided by 1023, then you multiply by 5, and you get 3 volt. Okay, so 614 you divide by 1023, which is the total, so you get a ratio, multiply by 5 volt, then you convert it to 3 volt. So we know that when the reading is 614, is actually 3 volt. Okay, so that is how you convert readings to voltage. Next, so first thing that we are going to do is we are going to use the potentiometer. Potentiometer is actually a variable resistor. There are 3 legs on the variable resistor. So there's the first and last leg. Depending on you put minus, plus, you put minus here and plus there. When you turn the knob to the other side, it will be maximum here and minimum value here. Okay, if you switch it, it will be positive here, negative here, it will be maximum here, and you turn all the way to the other side is minimum. Okay, and the analog output is via here. Okay, so it will get read, okay, by the board via the input. Okay, so this is the pin for it. Okay, next. So so this is the circuit that we are going to do for now. So let's start. Okay, so I'm going to take out a Arduino breadboard and the potentiometer. Okay, so I'm going to zoom in. So 5 volt. So I'm going to connect it the usual way, 5 volt. Okay, and ground. Okay, so next, after we are done with this, we will connect the A0. So the analog reading can only be done by this pin. So we are going to connect this to A0. We can't use the other pins. So okay, then next, okay, this is good. So we are going to connect this to negative and this to positive. Okay, so that is how we're going to connect later on. So I'm going to just start to code. So for these, we are going to throw away these, and then we are going to say that print to serial monitor. What we're going to print, we are going to print input read analog pin A0. So whatever is read by the potentiometer will be output to the serial monitor. So I think that will do. We don't actually need to wait 100 millisecond unless you want to slow down the reading. Then you maybe want to add that. Okay, so I'm going to just start the serial monitor. So because we put negative on one side and positive on the other side, so now this is minimum 0. Then we turn to the other side, 1023. When you turn to the center, it's about 511. Okay, now stop. Okay, so this is how you can do the reading. Now if you want to see a graph, you can actually see from the plotter. So you just click on this button, and then we can start simulation again. And when you turn this, okay, you can actually see that it's plotting a graph, okay, based on the value. Okay, stop. Okay, so what if we do another thing? Let's say I'm going to just pull this to one side, put the other one to this side. So we are swapping. Okay, we swap the positive and negative. Let's see how it goes. So let's start the simulation again. Now, so if we turn to this side, now it's 1023, and you will turn to the other side is actually 0. Okay, so swapping, as I showed you, as I told you before, it will actually change how this thing gives you a value. So I actually like it to be this way. So I'm going to just swap it back. Okay, so like this. So next, so now that we have the value, we can actually start to work on our board in here. So what I like to do is I like these three grooves to actually face me. So let's just try to focus it. Okay, so these three grooves I like it to face me. So actually it is to tell you the position of the pins at the when you plug in, you can't see the pins, so you actually know where are the pins. So I like it to face me, and I like to use the one all the way to the end. So I just plug in anywhere. Okay, so I just plug it to here. Okay, and then we have some space. We are going to start to plug in the cables. So for now, I'm going to just plug in the positive, negative according to what we see on the Tinkercad. So this will be on positive, the other one will be negative. Okay. And then we have one more. So this one straight to A0. Connect these to here. Okay, and we have two more. One to connect to the net positive. Yeah, I'm just going to connect the positive, and then I'm going to connect the other one to negative. Okay, that's it for this setup. Okay, next we are going to start to write the code for this. You can choose to go to code, go to blocks plus text, and then you copy out the code, okay, and paste it in. Okay, but I'm going to write it manually. If you look at the blocks plus text, you will see that they declare pin mode A0 input. Actually, that's not necessary. You don't really need to do that. So you can choose not to do so. Okay, for analog input, you don't need to declare. So I'm just going to write it from scratch here. So what we need to do is here, new line serial dot begin 9600. Okay, semicolon. Then from here we will just say serial dot print line. Okay, and then what we say is analog read A0. So whatever is read, it will just print it. So we are done. I'm going to flash this. Okay, I'm not going to save this. Actually, I just realized that we don't really need to save this in order to push it in. But it's good for you to save lah. If you should keep a record of what you do. Okay, unless you know it lah. So I'm just not going to save this. I'm going to just I have not plugged in the circuit, so I'm going to plug in. Okay, I have not plugged in the microcontroller. So now I'm done. I'm going to push it in, escape. Okay, good. It's uploading. Then go to tools. We can first go to serial monitor. So serial monitor now is saying 0. Okay, 0. So if I turn this the potentiometer, you can see the number starts to increase. I can turn all the way to the other end. Yes, and it's 1023. Okay, so this is how it works. So for this is a serial monitor. We can also open up a serial plotter, and when we open up a serial plotter, this is how it looks like. And then we can just turn the knob, and then it will actually draw the graph. Okay, so that is what we did in the simulator and how we do it in the circuit. Okay, so next, so we have this done already. Next thing that I want to do, okay, we're gonna unplug this. Now that we can do this, we know that 1 second is equal to 1000 millisecond. We know that analog reading is 1023, okay, maximum. So we are going to use this to modify what we did previously on the blinking LED. We are going to adjust the delay for the blinking LED using the potentiometer. So we are going to plug in the LED. Okay, and use a resistor. Oh, by the way, this one is not very important, but the one in your kit is actually at 10k ohm, so I just leave it as 10k ohm. Okay, so this should be okay. We have it 330 ohm, so I'm going to just type in 330 ohm, and then we have another cable to we are going to connect it to pin 6. This is orange. Okay, maybe you don't use orange again, we use green. Okay, done. So next we are going to code this. So I'm going to just dump this. Then output set pin 6 high. Then we use a delay, wait, milliseconds, analog input, okay, analog pin. So you wait for the number of seconds that is read from here. Then we duplicate, we set this to low, then start simulation. So now it is blinking at once per second, about there. Then what we do is we turn this to here. It's blinking at half a millisecond. Then when we turn all the way to here, it will be blinking at a higher rate. Then if we go all the way down, okay, it's like this. I think on and off is too fast, so it will be dim. But when we turn it up, then it will be okay. Okay, so this is modification of the blinking LED. We are going to try this out on the hardware. Okay, so I'm going to just plug in my LED, and then plug in the resistor. So make sure you are using a 330 ohm, not anyhow use the resistor. Always check, know which resistor you are using. So you are not doing those pull up, pull down resistor. You should be using the double orange. Okay, this one, the double orange. Okay, so I'm going to plug this to negative. Okay, then we're going to do is pin 6. Okay, done. Let me just refocus. Okay, good. Then we are going to write this. Okay, so I'm going to just I'm going to modify. We don't need the reading already, so I'm just going to delete the serial dot begin. Instead, I'll need to say pin mode 7 output, no 6 output. So I plug into pin 6, so it should be pin 6. Okay, so pin mode output 6. Again, same thing. You can actually look at the Tinkercad and just copy and paste it if you are not sure. Okay, but it is good to try and code it on your own. Okay, so next is we will say digital write. This time around we are using digital write 7 high, and then after that we will say delay, but instead of delaying the fixed second, we are going to say analog read. Whatever value that you read from A0, that is the amount that you should be delaying. Then we copy and paste this, and then we say low. Done. So I'm going to try this out. Oh yeah, wrong. This one should be 6. I keep thinking it's 7. So done. Okay, this is done. Yeah. Okay, we are going to just flash this now. Oops, not plugged in. Okay, uploading. Okay, done. So now it's blinking at once per second, and if I'm going to turn this, okay, you see that it's actually blinking at a faster rate now. Then if I turn more, okay, blinking very fast. Okay, so it works. If I turn all the way to the end, okay, solid. Okay, so it works. Okay, next I'm going to plug up the power. So we can actually do this with adding LED, extra LED. So this is one. Okay, control blinking rate of LED with potentiometer. Next one that we can try. Okay, maybe we can try to do this number two. Okay, number two. So I'm just gonna do this on here. So this will be, I want to change this to green. Okay, and then copy paste yellow. Yeah, I don't have so many bulbs later, so maybe I need to reuse color. Orange, copy paste, and then blue, copy paste, red. Oops, this should be red, green, yellow, orange, blue, red. Next is white. Okay, white. Okay, done. Then we can just copy paste this. It's easier on this simulator. We can just copy and paste things. But it's gonna take a while when we do on the microcontroller, our hardware. So 7. I was just going to change the colors. Yellow. I have another one. Okay, any pin will do as long as you know where they are. Orange. Then I have blue. Okay, blue. Red. Yeah, I like to have it like this. Next 11. So I'm just going to continue upwards. So that's why I'm using 6, 7, 8, 9, 10, 11. White. Okay, we have white. Okay, nice. So we are going to try this out. So map. Okay, I'm going to just throw away this. Next. So what we can say is that if I want to turn this knob and say that different segments of these 1, 2, 3, 4, 5, 6 in different areas, it will light up different LED. Okay, different LED for this. So what we're going to say is that if there are many ways of doing this. So what I'm going to say is that if equal, so we're going to say whether is it in different segments. So if it's equal to a certain segment, we are going to do certain thing. You can play around with these conditional statements, but what we're going to introduce you is map. So map, what does it do is that it will map the range to. So let's say we are mapping digital analog pin, input analog pin A0. So it will actually map. Maybe it's easier to explain using these blocks plus text. So what it's going to do is it's going to map 0 to 1023 to 0 to 180. So the values for this potentiometer, when you turn it into the center, is about 511. Okay, how does it map to 0 to 180? It will be 90. The value that is given will be 90. So actually mapping is just like a adjusting the range. It can be it can don't start from 0, it can start from any number. So if I say that okay, maybe we should do an exercise to explain mapping before we carry on from this. So I'm going to just delete away. I'm going to just say that output to serial monitor. So serial monitor is actually very good for us to actually do testing, to do test and some ideas. So I can say 0 to 6. Okay, so what this is going to do is that when I turn the potentiometer, it will actually report a different value. So we are going to just adjust this, then you can actually see what I mean. I'm going to start simulation now. Okay, so now it is 6. 0 to 1, 0 to 3, but it's now saying 6, 5, then after that 4, 3, 2, 1, 0. So actually we can actually change it to do this. So we can say 0. So 0 to 1, 0 to 3 is now 0 to 6, I think. 0 to 6. Yeah, 0 to 6. We can also stop simulation. We can also say 1 to 6, or maybe we can even say 3 to okay, maybe we do a different thing. Maybe I say 2 and 2 to 3. Okay, clear this out, start simulation. So here is 2, and when we turn it all the way to the center, to the other side, oops, 3. Okay, there's something wrong. Yeah, I can't really split it to 2, 3. Okay, never mind. You can try 0 to, okay, let's just put 0 to 5 lah. Okay, let's just see how it goes. But what we're trying to do is here 0, then 1. So when this in this region is 1, 2, 3, around there lah. It is roughly 3, 4, and 5. Okay, not very accurate when you do the splitting of the 0 to 1, 0 to 3 to the whatever number. But what we want to use is, now we already split to different region. 0 to 5, there are 6 numbers. We are going to light up different LED. So we are going to stop this simulation, and we're going to start to code out this portion. So it's not very nice, not very nicely separated lah. But never mind. Well, as long as we are able to control all our LEDs, I'm just going to do that. So if else equal, if it's equal to, if I map the analog pin to 0 to 5 and it's equal to 0, I'm going to do something. Okay, I'm going to output. So I have 6, 7, 8, 9, 10, 11. So I'm going to just set pin. Okay, I'm going to just put 6. Okay, duplicate. Plug in 7. Duplicate this again. Oops. Can't do. Never mind. Duplicate again. 6, 7. Duplicate. Okay, plug in. Now I have 4. And then after that, I can duplicate another time, and then plug in again. 6, 7, 8, 9, 10, 11. Okay, so all are high now. Maybe I'll just all of them should be only one of them. Maybe I just maybe I don't. Maybe I just sorry, just put 0 to 6. It will auto split for us, So I'm just to say all is low. Low. I'm going to do it differently. I'm not going to do it the usual way I will do it. I'm going to just say all low, and then the next thing I'm going to do is I'm going to duplicate the entire block. So entire block, but here if it's 1, I'm going to say high. Okay, and then after that, going to plug into Okay, you drag it up a bit, apply it to here. Now this is map to 0 to 6 is 2, and then we will say low, high. It's up to you how you want it to be. Okay, maybe I'll just leave it at high. Then duplicate this. Okay, and this will be 3, high, duplicate, 4 highs, then duplicate, 5 high. Six high. Okay, done. So I'll go to just run this. So the coding should work lah. So here now is like this. When I turn all the way down to the end, okay, no LEDs up. When I turn this, first LED is up, second LED, third LED, fourth, fifth, and last one. Okay, so so this one way to control the LEDs. Okay, so you may want to do this on the circuit. Okay, so maybe we'll do it. Yeah, I'm just going to try and do this. Maybe I'll just do a few. I'm not going to do the whole range. Okay, so I'm going to just do a few. I think a few will be good enough. Oh, so but this next one. Then okay, I'm just going to plug 3 lah, because I only got 3 types of colors. Don't have a lot of time, so I'm going to just do 3. You can do how many you want. Okay, so 7. And 8. Okay, done. So this is all good. Then we're going to continue already from here. We'll just drag this out a bit. Okay, so we actually can write a if else statement for this. So 6 output, we can say we can copy this, copy, paste, next 6, 7, 8. Then we can have delete this. So we will just put it as if if so we can go and refer to this code. Okay, you can actually look at it blocks plus text. So we can actually say if map this is good, we will just copy this portion here, so it's simpler. So I'm going to just copy and paste that here and then modify from here. So if map analog read A001023 to 0, now this one we don't need to map so many, so I'm going to just say 01 2 3 0 1 2 3. Okay, 0 1 2 3 equal to 0, then we will not light up any LED. I'm going to delete this. Okay, good. Then what we will say is we'll digital right 6 low, and then we will have copy, oops, paste 7 low, and we have this 8 low. So very simple. We are just going. So this is like this for the first statement. So I just copy and paste this. Okay, there are other ways of writing it to keep it things even shorter, but I think this is quite a simple way of writing it, so I'm going to just do so like this. So hi 1, okay, and then after that next I'm going to just copy and paste. This will be 2, this will be high, okay, and next copy, paste 3, high. Okay, I'm done. So I hope this works. I'm going to plug in my power. Okay, so we only did some minimal changes. Actually, this you can, if you do all 6, you can actually just copy and paste. But just do 3 and I just do some modification to this. So I'm gonna go to here, and I'm gonna just push this in. Escape. Okay, done. So if I twist this now. Okay, first LED, twist some more, second LED, twist all the way, third LED. If I twist back, okay, you can actually see that the LED will switch off. Okay, so maybe my hands are too fat, too big. So yeah, just use these to turn. So turn this, 1 2 3, turn back this, switch off. Okay, so whatever you want, you can actually do many other type of pattern with potentiometer and LED. Next what we are going to do is we can actually do, using the same logic for mapping, we can actually do something else. So I'm going to just clear out these things first. Okay, I'm going to just clear out these things. Okay, so okay, delete. Next, what we are going to do is Arduino, rotate. We are going to do the third example. Okay, we need to quickly do this example. Okay, the next one is this potentiometer with the piezo. So I like to call it a piano. So I'm going to put this in, and I'm going to put this breadboard small. Okay, and next we're going to put in the potentiometer. Okay, and then we can put in the positive, negative. Okay, escape. Don't need the positive direct to 5 volt. Okay, because there's the other one, there's no need for it. So just read, and then I have okay, I just drag it to here. Then I have another one to the negative. Yes, this one we will need to have another cable, so I'm just going to connect this to the ground. Then I'm going to have one more to A0. So this one will be orange. Okay, then we have the piezo. Okay, then done. Then the piezo we will have one to maybe pin, let's say pin 7. This will be green, and then we have one more to the ground. Okay, that's it for this part. Next thing we are going to do is we are going to do I'm going to write the code for this. So what we're going to do is delete this portion here. We're going to say that play speaker on pin 7 with tone. Which tone do we use? I like to map these input analog pin A0, map it to a range of 50 to 75. I think this is more sensible for 1 second. Then we need to have one more if you are going to want it to play for 1 second. I think I like it to play for 100 millisecond will do. Okay, so it will play for 100 millisecond, repeat. So 100 millisecond is a 0.1. Okay, 0.1 second. So that is what we put in here. Then when we start this simulation, okay, speaker volume. Okay, so this is my piano. The piano is done. Maybe we can we will do this on the hardware now. So I am dismantling my setup for the previous part. Okay. And okay, so this is okay, this is good. What we need is we need to take out the temperature sensor. Before we do that, I'm going to just go through some parts of the slides. So here, so temperature sensor for Tinkercad is actually very simple. The temperature sensor pin A0 in unit degree Celsius. That is the one that when you plonk it in, it will actually do the calculation for you already. But later I will explain how this does the job. Actually very simple. You just need to delete this. Yeah, I'm just going to delete this and delete this. Actually, we don't need a lot of things. We don't need this also. Not very a lot of things don't need. So this one also don't need already. And what we really need is only. Okay, I'm going to just delete all this. Don't need all these things. You only need to take out this temperature sensor later, and the temperature sensor will have these legs power analog reading. This is a voltage out lah. So this one will go to A0 and this one will go to the ground. Okay, so this is what we actually will need. You only need one temperature sensor. So the temperature sensor looks like this. Is a very small thing. Later you can see in the box. Now if I change the code, you will see that blocks plus text. Okay, blocks plus text. If we take this out, okay, and then we just put in output. Now you see how Tinkercad actually help to simplify a lot of things, but you really need to learn how to actually do the coding. So you see when I plug in this code, it will actually write out the formula for the calculation or for the pin A0 to degree Celsius. Later I will explain this part. We are going to go back here. So the temperature sensor sends about -50 to +125 degrees Celsius. That is the range. Okay, so when you plonk in these are just decorative lah, so I make it look nicer. We don't want it to spam too much, so we wait 1 second. And the legs are positive. This to the A0, and then this is negative. Now warning, never swap the positive and negative. You swap the negative and the positive, what will happen is that the temperature sensor will heat up and then you burn your fingers. Now this temperature sensor is like a cylinder sliced into half from the top. So it is there will be engraving TMP. Now there is others that look the same as it, maybe the NPN transistor. So NPN transistor actually looks like this, okay, this type. And then so NPN transistor is like that. Then you have the TMP36. Okay, TMP36, how does it look like? It is like this. Now they all looks the same lah, all looks the same. So don't get confused. It must have the TMP engraved onto it. So make sure that you use that. Your box only has this, so that you don't get confused. Okay, maximum your output is 1.75 volt. Make sure you don't swap them. Make sure the flat face is facing you. Okay, so we are going to plug this in, we are going to run this, and after that we're going to do this on the circuit. Then after that we explain the code. So let's start. This one I'm going to delete. I'm going to just connect 5 volt straight to here. Okay, make sure you connect it correctly. Red, you can see from here, you hover over power. Next, this is ground. Okay, black, and then we have one more to A0. Okay, done. I like you to use the breadboard, not the male to female cable to connect the temperature sensor. Okay, just plug into a breadboard, and later you can do this. Next, we are going to say print to serial monitor degrees Celsius. Then we will put in the weight. 1 second. Okay, I'm going to just go back to blocks. Going to start this simulation. Okay, so it is reporting it as 24.92 and it's 25. When you slide up to maybe 125, it will report 125. When you slide it a bit down, 111, it 111.82. Okay, so when you slide these 3, it will be about 3.933. Okay, so it actually tells you the temperature using just like this. It will tell you the temperature already. Okay, so of course if you want to make it nicer, we can just go to output, print to serial monitor without new line. So we will just say temperature. Okay, and then after that we will put in another one here with new line now with a C. Okay, so now what it will look like is this. Okay, so it will look like this: temperature 24.92 C, 24.92 C. So it was right here. Okay, it just looks nicer. Okay, next, we are going to look at the code. So if you look at the Tinkercad, this is the formula that I use. Okay, but it doesn't it's not meaningful lah. If you read this, you don't know what is it about. So I'm going to just explain to you what is this code, how we actually write it, usually how we actually program this. So this is a very short code to keep it simple, but in order to understand how the code works, we need to look at this. So I will create two variables. One is called voltage and Celsius, so that it holds the voltage and Celsius values. Float, why are we using float? Because float stands for floating point number. Okay, it just means floating point number. So floating point number is any number with a decimal place, floating point. So that is a floating point. Any number with decimal is floating point number. Okay, so why are we using floating point? Is because we want it to be accurate. Okay, so we want it to have a decimal point. Next, so we float voltage, Celsius. These two don't need to explain anymore. I think you should know. This one, voltage. So how to calculate voltage? We take, just like just now we say about 614 divided by 1023 times 5. Okay, whatever reading divided by 1023 times 5 converts the reading to the voltage. Okay, to the voltage. So that is how we convert. So all the analog, all the sensors actually just gives value 0 to 1023. Then it converts. You need to convert it to a meaningful value for you. You do the calculation. So voltage is calculated. We take voltage minus 0.5 times 100 is equal to Celsius. So according to this, if you look at this, 1.75 minus 0.5 give you 1.25. 1.25 times 100 give you 125 degrees Celsius. 0.5 minus 0.5 is 0. 0 times 100 is 0. So that is how you calculate. So this is the voltage to Celsius formula. Okay, you Google for it, it will show you 0.5 multiplying by 100. Okay, so by minus, because the range that it reads is actually minus 50 to 125 degrees Celsius. That's why it's minus 0.5 times 100 lah. Okay, so then this is the what we use to do the printing. Okay, same thing that we did. So without further ado, we are going to quickly go and do this on our board. Okay, so yep, let's unplug this and let's see how is our cabling. This is wrong. We are going to swap things out. Okay, so that one is for the potentiometer. I'm just pulling out all this so that I can plug in the temperature sensor. Make sure you plug in things that are correct. So I'm going to just so my red is my positive, my blue is my A0, and my red is positive, my black is negative, and blue. So I plug in like this, and then I take out my temperature sensor. Yeah, I plug it into here. Okay, they are good. We shall plug in the power. Okay, make sure you check, make sure that you don't plug in the legs wrongly. I'm going to plug it in here now. Then I'm going to just go to here. Okay, I'm going to go and convert to text. For this time, I'm just going to copy this. I'm going to paste this over here, delete, paste, and push, escape. Then tools, serial monitor. Okay, so now it's reporting the temperature as 25.9, 25.4. I don't think it's so cool. I'm going to put my finger on it. Okay, you can see that the temperature is starting to increase. Okay, because my finger is on it. Now if I let go of it, okay, I'm going to let go of it. Okay, it starts to drop back to, later in a while it probably will drop back down to 25. It's not dropping further. Okay, anyway, so you can actually test it. You can, but don't go and put it in water, or don't go and, please don't go and suck it or put it in hot water. Okay, so the temperature sensor is not not accurate for now lah. It needs to be calibrated, because it's not calibrated. What I mean by not calibrated is that you need to calibrate it with a real thermometer. So you need to check the real thermometer, and then if the value is different, okay, let's say now it says that it's 25 plus, but actual temperature is 26 plus, and you need to adjust. Then what you do is that you can go and come here to calibrate it by +1, -1 to adjust it to the actual temperature. Now it's not calibrated, but it's actually precise. Okay, so if I say +1, I'm going to flash this in, escape. Okay, then what happens is that the temperature will be adjusted by adding 1. So you can see now instead of 25.41, it's 26.41. So this is how you can adjust by plus or minus from that number to adjust to calibrate the temperature sensor. So that's all for this lesson. Thank you.